Hello. So here is a pretty cool, interesting way to divide by 9. So in this example, we have 23,102 divided by 9. And what we can do is just go ahead and read our number 23,102, but as we go along, we just take the partial sum. So we have our first digit here is 2. So this is going to be equal to 2, but then we have 2, 3. So we do 2 plus 3. So that's 5. So we have 2, 5. And then we have 2 plus 3 plus 1. So that's 6. And then 2 plus 3 plus 1 plus 0, which is another 6. And then 2 plus 3 plus 1 plus 0 plus 2 is 8. So and that becomes our remainder. Our last sum is our remainder. So we're saying that 23,102 divided by 9 is equal to 2,566 with a remainder of 8. So why does this trick work? And would it always work? Well, we're going to explore this using exploding dots and using a 10 to 1 machine here. So we have our number 23,102 represented in our 10 to 1 machines. We just have 2 dots, 3 dots, 1 dot, 0 dots, and 2 dots. Now we're dividing by 9, but we're actually going to think of 9 as 10 minus 1. Okay, so we're going to think of 9 as 10 minus 1, which it is, and 10 minus 1 in a base 10 machine would look like 1 dot next to 1 anti-dot, right? That's 1 dot in our tens box and then an anti-dot in our ones box. So that's 10 minus 1, which is 9. We could always unexplode this dot, become 10 dots. We'd have 1 annihilation, and then we'd still have just 9 dots in our ones box. So this is 9, but we're thinking of 9 as 10 minus 1. So to do this division, we're just looking for the pattern of 1 dot next to 1 anti-dot. Okay, well, let's look at our dots here of 23,102. And, well, right away, we don't see any pattern of 1 dot next to 1 anti-dot. Well, if we want something, let's go ahead, let's make it happen, but then let's deal with the consequences. So what we want is we have these 2 dots all the way in our leftmost box here. And we want a pattern of 1 dot next to 1 anti-dot. So if we just go ahead and put in an anti-dot, well, anytime I put in an anti-dot, I'm going to have to put in a dot as well. So, but then we have one pattern here of 1 dot next to 1 anti-dot. If we do it again, put in another anti-dot and a dot, okay, then we have these 2 patterns here, 1 dot next to 1 anti-dot, and again here, whoop, 1 dot next to 1 anti-dot. So there's 2 patterns at this level here. There's 2 patterns, okay, but then, well, how many dots are in this box now? Well, we have 5, right? Or 2 plus 3. So now we want an anti-dot to go along with each one of these dots. So we can go ahead and put them in here. We want 5 anti-dots because 1 anti-dot to go along with each one of these dots. So 1, 2, 3, 4, 5. But anytime I put in an anti-dot, I'm going to have to put in a dot as well. So I'm really not doing anything. So it's 1, 2, 3, 4, 5 dots. Okay. And then we see 5 patterns at this level here. But again, we picked up 5 dots. Or, well, right now we plus that dot that was already there, right? So we have 6 dots in this box, and we want an anti-dot to go along with each one of those 6 dots. So we have to add in 6 anti-dots here. 1, 2, 3, 4, 5, 6. But then, well, we're going to have to add in 5 dots as well, or 6 dots as well. So 1, 2, 3, 4, 5, 6. Okay. And then, well, we're going to see again. So we have, again, here 1, 2, 3, 4, 5 patterns. So 5 patterns at this level here. And then we have 1, 2, 3, 4, 5, 6 patterns. 6 patterns at this level here. But then we have these 6 dots. So we're going to have to add in 6 anti-dots in our last box. 1, 2, 3, 4, 5, 6. But then after we do that, we have to add in 6 dots as well. 3, 4, 5, 6. Okay. And then, well, we see 1, 2, 3, 4, 5, 6 patterns at the ones level, but then we have these 8 dots left over. So what's the answer? Well, we have 2 2 patterns at this level. So we have 2, then we have 5 patterns at this level here. So we have 5, then we have 6 patterns here, and then we have 6 patterns, and then we have another 6 patterns, so another 6 there, and then we have 8 dots left over, so therefore we have a remainder of 8. So yes, right, that explains, right, why we can go ahead and just add the partial sums and then just write down the answer right away when we're dividing by 9. And we can see that if you think of 9 as 10 minus 1 in a 10 to 1 machine. Okay, but did I pick numbers here that worked out pretty nicely, right? Because we add 2 plus 3 plus 1 plus 0 plus 2. Well, every time we get an answer, that is, well, less than what? Less than 10, right? We never have any explosions. So what if I picked some different numbers? What if I picked something else? Let's say, I don't know, 25,000, maybe 700 and I don't know, 28 divided by 9. Well, then what would happen? And well, would the same thing work? Could we still take the partial sums and just write down the answer? I think we actually could, but there's something else to think about with the explosions that would have to happen. So I'll let you go ahead and think about that. But yeah, pretty cool that we can explain this arithmetic trick here with exploding dots. Take care.